Uh, Hi everybody. So I guess this is episode 2 of shimavlogs3000. Um, I feel really unprepared, but I think I just want to wing it, and hopefully that's what this is supposed to be, is me winging it. I don't know if I'll be able to filter out all the fan noise, so I don't know. We'll see what happens. But it's hot outside, and I just want to be comfortable. Maybe I can rotate the mic away from the fan. So I've been working a lot, really hard on these paddle controllers. I forgot how much I talked about last time, but it's been a couple weeks. The most recent updates include, so mainly I'm working on the USB version of this paddle controller. And for those who aren't familiar, I think back in the 70s, I think I'm going to say this every time I talk about paddle controllers, but back in like the 1970s, maybe early 80s, just a lot of video games, or a lot of computers in general, had as their inputs, everything was analog back then, so one of the most analog things is a thing called a device called a potentiometer, which is basically just a volume knob. Think of it that way. So the potentiometer tells the computer some way of communicates to the computer a voltage. The computer can read that voltage and then convert that into an input that controls something on the screen. So I have this new, I think I showed the prototype last time. Let's go to the big camera. Yeah. So this is, this is the real PCB of the prototype. I think I showed something that might maybe look like this last time. This is a plastic 3D print of the actual circuit board, but it has like ugly wires on the back. And the new PCB version, it just has all the wires are like hidden away in the the layers of copper, I guess is what I'll call it. This is great because it was so easy to assemble and relatively low cost. So basically it consists of the microcontroller here, which is also the USB connector. And all we do is we tell the microcontroller whether we want to press the button or if we're changing the voltage of the potentiometer. And in the old days, there was like something that looked sort of like this, which was like mainly, this was sort of designed based on the Atari controller, the paddle controller. So you would rotate left and right so the computer could see left and right, and then there was always just one button. And it's a good simple design, which I wanted to replicate. The really cool thing, so originally I didn't want to make a device that was just a single paddle because I felt like it was a waste of all these pins. There's like 16 pins around the microcontroller, because basically the potentiometer and the button, they only occupy 2 pins on this thing, and there's so many more. So like this could become something much bigger. It could become a controller that has all the buttons. So like this is a retro handheld that has all these buttons and the two joysticks. It has the D-pad, the buttons, these two buttons. It has the bumpers and the whatever. All of those inputs, actually, there's probably too many inputs, but most of those inputs can be connected to the microcontroller pins. And if there were more buttons, I would use a shift register and rewrite the code to use a shift register. So it would have like 2 chips on it instead of just the one. But what I want to talk about is one way that I wanted to maximize the use of the microcontroller is to give it 4 connectors. So like I'm using RJ11 connectors, which are like old telephone wire. It's the reason I chose it is because it's so common and cheap, and a lot of what I'm doing is trying to make these things available very easily, so people can either build these themselves, or I could build them and charge very little for them. So it's the same microcontroller. You know, I kind of over-engineered it by adding a little capacitors to like filter out noise, and these resistors are actually, they're very important. That's not really over-engineering, but it does keep these button inputs, the button inputs, which are part of the controller, I should say. I was like gonna try to point to a button. It when you're not pressing the button, the signal needs to be pulled up. So these are pull-up resistors. And the ends of each of these has a dangling oh boy, has a dangling paddle. And so the really cool thing is these are very low cost. These are purely analog paddles. It's really just the button and the potentiometer. Yeah, this is where the over-engineering comes in. There's a pull-up resistor and a filter capacitor here, and that's totally redundant because they're already over here as well. For sure it'll be a very, very clean circuit, but I could probably remove the. I think it makes it more universally useful. Like this, I call these satellite paddles. These can be reused in a number of different circuits, so I think that's why I over-engineered it that way, so that it's a standalone device with a clean signal. So I kind of want to show you how it works. So I think this is hilarious. I think I can try to plug this in without bringing down the house of cards. So I'm going to unplug. I had this plugged in temporarily. This is one of the other prototypes. You can tell it's a standalone device because it has the microcontroller. So I've got the same USB cable here. So we'll plug it into this guy. And then let's switch to other camera. So what I like to do is check it. Let's see if I can bring this web page over. So hardwaretester.com/gamepad. So if I take the player 1 paddle, this one over here, where's my, okay, this one here. Let's try to zoom up on this. Can I zoom up? So the hardware tester can see the name, so I named it in the firmware, and when I turn this knob, you can see the value of axis 0 go from -1 to +1. So you know that that's working. It shows that axis 1 is kind of wigging out, but that's probably okay. Yeah. I think it's the conversion between analog and digital, and there's always a little precision problem. It's not really a problem, but digital looks worse, makes things look worse. And if you press the button, you see B0 get triggered. So that's B0 getting triggered, and my axis is moving. And I also have my other controllers, so let's go. We got player 1, I guess we'll call that. Player 2, actually, or axis 1. For some reason it's grayed out at the bottom over here. I don't know if you could see that, but it's going up and down, and then if I hit the button. So this is just how I arbitrarily configured it, because it's not exactly a strong standard, I don't think, because people don't really use paddle controllers. But I want to change that, and that's kind of why I'm making these videos. I just want to be like, it's kind of my way of saying, what happened? Why did people forget that these exist? Like, why did they basically design a gamepad with 2 joysticks, which is 4 axes, right? And each of the 4 axes can be a paddle controller. Why did they make 4 face buttons when each of the face buttons can be assigned to a paddle? Like, it so perfectly lines up. So I went with axis 0, 1, 2, 3. Even though there's a kind of discrepancy somewhere where the 4th axis is either axis 3 or it could be axis 5. It's a very confusing thing. And I think once this hardware gets out there into the world, I assume some people will buy them, that we could iterate on the firmware. So let me just show you. If I bring up the Arduino, maybe I don't have it open, hold on. Arduino, let's use my search. So if you look at my Arduino code, not now, whoops. So if we look at my Arduino code, this is the description that gets sent off to the, I don't know, USB universe. It's how the computer sees the USB information from the device. I arbitrarily chose this. Whoops, sorry, my timer is going off. So I have my x-axis, y, z-axis. So that's where axis 0, 1, and 2 come from. Axis 3 is what I wanted to see, but when I asked AI to help me configure a standard for the 4-axis controller, it gave me this hex value of 0x35. So hex 35, for some reason, that's axis 5. But I wanted it to be in just logical order, 0, 1, 2, 3, 4. So I changed it to 33, to hex 33 here. So now somebody else might do more extensive research and find that using axis 35 in hex is the more popular 4th axis than 33. So it, it's all very arbitrary, because within the software, the game that you're playing, it's usually configurable. So let's talk about that. Let's quit this though, and let's switch over to Stella. Now this is the game. This is the reason this controller exists. is to play Warlords on Atari. So here's Stella 7.0 running on my Mac. It's the standalone version of Stella. And I want to go to options, right? I want to go to inputs. And I want to warn you in advance that sometimes when you're messing around with these paddles, because they use the standard controller interface, so it looks like you're messing around with the joystick when you're turning these knobs, the interface might react. So if it sees me turning axis 0 to the left, it might actually think I'm trying to go left. So if the interface supports going left, I might be changing values by accident. So just a little heads up for when you're trying to do what I'm doing. So this is what I want to show you. I'm going to take a chance here. I'm going to switch to defaults. I'm clicking defaults. So now we're all on level playing ground. If you're following along, if you've found this video in the future and you have one of my paddles or you built one from scratch, more power to you. We're going to look at left paddle A. So there's left paddle A, left paddle B, which means you're plugging into the Atari port on the left, and you have two paddles. So paddle A, by default, it shows up as controller 0, C0, and the x-axis. Is that right? Let's click defaults. That's correct. So to be totally honest, that's already set the way you want. But that's the only one I think that comes up correctly. So if I erase this so that it's got nothing and I go to map, now it's asking me to basically move the paddle. So I'm going to rotate it left and right, back and forth, in front of the camera. Oh, it took a while, but it finally read it. So it changed the value. And then I'm going to go to the fire button and click on erase and map, and I'm going to do the same thing. I'm going to press this button and it's going to register as controller 0, button 0. So that one's done. Now I'm going to go to the next port where I have another one of these, and here we go. I'll try to do this a little faster. This one has nothing mapped. So this is the paddle, so I'm going to rotate it. Okay, it shows up as axis Y, which is what we expected. I'm going to go to the fire button. I'm going to erase that and then hit map and press the button. That's correct. Button 0 or button 1. Okay, and now we're going to go to right paddle A analog. Right paddle A analog, which is, from my point of view, it's the third controller. And I'm going to hit map and rotate. It should show up as axis 2. Yeah, or z-axis, XYZ. And then the fire button. Whoops. See, that's what I mean. If you press, let's cancel what I just did by accident. Okay, let's try that again. I think it remembers all the settings I previously set up. So A analog, A fire, B analog, B fire, right paddle A analog, that's correct. And the fire button, right paddle A fire, erase that, go to map, press it. Okay. Promise, only one more. B analog, map that, pick up the final controller, rotate that until it picks it up, go to right paddle B fire, erase that, hit map, press the fire button. So if we look at the analogs, the analog axes, we got axis 3 going backwards, 3, 2, Oh, wait a second. Oh, Z, sorry. It goes axis 3, but it renames the convention, switches from numbers. So that's funny. So it's using X, Y, and Z conventions here for the first paddle, the second paddle, X, Y, Z. But then it switches over to a number convention for the fourth paddle. It calls it axis 3, so 0, 1, 2, 3. That's very funny to me, but you know, maybe people are like, haha, whatever. Okay, so I'm going to hit OK. I'm going to close that. Now we're going to run Warlords. So Warlords by default is in 4-player mode. So I have it mapped, I think it's by default mapped to the F keys. So F1 switches through, is the select button. So you can change the game mode. But we want to be in game mode 1, which is only 4 players mode. So I guess I don't really know what the other game modes are, but I know that I think the number to the right that says 4 is the number of players. And now if I hit F2, that starts the game. So now we're in F2. If I'm in the controller 1, it's the upper right. So I'm turning to the right. The player goes all the way to the right side, I guess. We go left and it goes towards the left. And if you hold down the button, your player will grab onto the ball, or whatever that is. And now if I release, okay. And now let's go to player 2. This is player 2. So if I go to the right, it goes to the right. Go left, it goes to the left. And I should be able to catch that ball. Ah! Alright, I can't catch it. But that's player 2. And we have player 3 might be the dead guy. Yeah, player 3 is the dead guy. And player 4. Catch it. No. Yeah. Okay. Okay, so that's obviously this would be better if I had friends here and we were playing the game. But that's just me playing 4-way Warlords with myself. Or I could hit the select button and hit F2 to start, and then grab player 1 controller before I die. Let's play a little Warlords. And maybe do a slow fade out. But I hope this has been interesting. I hope that there's people out there that are using Stella or know how to download it or are interested in learning and want to play 4-way Warlords with their friends. And I hope that they will either look at my GitHub. I have to double check if all my files are updated. You could either build the controller yourself and use the same firmware I wrote, or I'll assemble a bunch of these, put them on my Etsy shop, which I hope to open someday soon. The other thing is, my controllers do work natively in my Game Tank game, which I think what I'll do is, well, I'm definitely going to release it on Steam. People might think it's too expensive, but I think what I'll do is make a demo version, and then if anybody plugs in a paddle, I think it'll unlock it so it's no longer a demo. Okay, so I'll just keep playing, and maybe editor me will do a fade out or something. Let's see. We'll see what editor me does. I play this a lot though, and I usually just kick the computer's butt really fast. One of the annoying things about this game, although I guess that's true about most multiplayer games, is after you die, you just have to watch your friends play. Actually, it's really lame when you're playing the computer and you die, and you have to watch the computer play itself. Alright, one more. Damn it. So close. Game over. All right, thank you.